All right, lesson 11, equations of all kinds of lines. So the first question here, which one does not belong? Claire. Why? The only ones where the lines are not parallel, only ones that will cross. Okay, somebody else other than B, what do you think?
C, because it's the only line that goes zero.
What's that called?
I don't know. Perpendicular.
A line.
A line.
They're all lines.
A line that.
I heard it. Horizontal. It's a horizontal line. Okay, only one that are horizontal. Okay, so I got a vote for B and C. Anybody else? Again, you could argue any of them. A, maybe the only ones that are negative slope.
D is skinny.
D, yeah, the ones that are the most narrow, maybe. But just make an argument for all of them. Whatever you choose is just fine. All right, number one, plot at least 10 points whose y-coordinate is -4. Okay, so somebody give me a point where the y-coordinate is -4.
Negative.
That's the x coordinate.
Yeah, so I need 2 points.
2 and -4.
2 and -4. There's one.
1, -5. Or -1 and 5.
The y-coordinate, the second number needs to be -4.
I'm confused.
So you can give me whatever you want. The second number needs to be -4.
Oh, the second number has to be -4.
And so far I've heard 2 and -4.
Can we go with
-1, -4.
0
0, -4. 1, -4. 3, -4. 4, -4. 5, -4. 6, -4.
7 negative.
72.
Sure. If you want to go all the way up to 9,
486.
you want to go all the way up to those numbers, that's fine. Plot them then.
82.
Okay, the point is, what do you notice about them?
It's
Horizontal line.
Yeah, so anytime you have the y-coordinates are all the same, you will get a horizontal line. Always is the case. Okay, question number 2. Which equation do you think would best specify that line? Give you 4 choices there.
the third one.
Yeah, the one where all the y's are -4. So anytime you see that, no x, it's just going to be y equals, it will always be a horizontal line. If it says y equals 4, there'll be a horizontal line at 4. If it says y equals 1, there'll be a horizontal line at 1. Only when it's no x, just a number, always the case. All right, number 3, plot at least 10 points whose x is 3. So that means the x coordinate, the first number is 3. I don't care about the back one. So somebody give me a point where the x is 3. 3, -2. 3, 4.
3 negative 5.
3, -5. 3, -4. 3, -3. 3, -1. 3, 0. 3, 1. And you'll see the point.
So on.
Okay? So what do you think on that one? Vertical. So anytime you have the x coordinates the same, you will always get a vertical line. Do not get those two things mixed up. Y equals horizontal. X equals vertical. Always the case. So if you go on the next page, which graph you think would best represent that? Which equation? X equals, absolutely. X's are all the same. Okay, so for 5 and 6 here, why don't you make a little sketch and graph those two lines? X equals, what kind of line are we gonna get? Vertical. At x equals -2. Y equals horizontal line, and it's at 5. Those are your two lines. Always going to be the case. Now, if you start throwing an x in there, of course, then you're going to add slope. But if it's y equals horizontal, x equals vertical, if it's just a number. Okay, are you ready? Draw a triangle with those vertices. So go ahead and sketch it out. If you got a piece of graph paper, put it on there. Plot those points.
Did you say triangle?
Maybe. Looks like it's a rectangle.
That's a square.
Okay. Wants to know the equation of every one of those lines. Should be simple. It looks like I have 2 vertical and 2 horizontal.
It's not a square now.
Can anybody give me an equation of any of those lines that make that rectangle? Let's look at the vertical ones first. Vertical, we said, are all going to be x equals. So what is the x coordinates of these 2 points? 2. So this line is x equals 2. This line, x equals 5. Done. 2 vertical. Now it goes on forever, of course, but we're just making a rectangle. So the horizontal ones, Adam, what do you think? Y equals what? How high is that one? 1. How about the other one? Count them with me. Ready? 1, 2, 3. 3, yes. There you go. Horizontal, y equals, vertical, x equals. Get it? Got it. Good. All right, so we did number 2. Question number 3. Okay, you can put this on the same, I think same graph. Now it does the opposite. It gives you 4 equations, and it wants you to find out where the points would make the new rectangle at. So put these 4 lines on your graph, and then wherever they meet will be your coordinates of the rectangle. So I'll give you a minute or so to do that. All right, x equals -1. That would be a horizontal line at -1. X equals 3. 1, 2, 3. Horizontal line at 3. Y equals -1. And y equals 1. So here would be my points. Kind of caught up to the other one that we already did. That's fine. So 3, -1. 3, 1. -1, 1. And -1, -1. Those would be your 4 points. So I could ask you to do either one. Graph it, what's the equations, or find the points. Either one of those is fine. Any questions on that? All right, last one. There are many possible rectangles that have a perimeter of 50. Complete the table with at least 10 rectangles. So that gives me a perimeter, a distance around of 50. So 1, 24, 1 and 24 would certainly be 50. So the two sides have to add up to 25. All right, so 1 and 24. Somebody else give me another one.
48.
Nope. That would be a perimeter of 100.
2 and 23.
2 and 23.
Keep going now.
What?
5.
5 and 20.
22
22
and 3.
and 3.
Oh,
21 and 4.
oh wait.
6
I
to
know what
19.
you have.
6 and 19. 10 and 15. 15 and 10. Two more.
4.
7, 18, 18 and 7. All right. Okay, from there, I would like you to plot those points. Width and length. So the first one is length of 24. This is my length, so 24 and 1. And put a dot. Okay, and it wants you to draw kind of what the rectangle would look like. So there's my 1 by 24 rectangle. Next one is 2 and 23, and draw the rectangle. Okay, so go ahead and put all your points on there from our chart. Draw the rectangle on the graph. All right, and of course there could be more than that, but you should start to see a pattern with these rectangles, and especially that point in the upper right-hand corner. Okay, these vertices all lie on a line. And that would be the case if we did them all. They're all going to be on that line. Okay, it says draw in this line for number 3. Write the equation for it. Now obviously we're going to have a slope, so it's not just y equals or x equals. What is the slope of that line? You could use any of those points, but you might be able to see it. No.
4.
Nope.
Maybe it's one of Ryan.
What?
Negative 1.
-1, right? It's going downhill. It's going downhill. It's down 1, right 1, down 1, right 1, down 1, right 1. And the reason that is, every time you lower one of these, the other one gets bigger by 1. It is -1, and you could put a 1 there, not required. What is the y-intercept? 25. So that needs to be part of my equation as well. So that's probably the most basic equation we could write. Slope of -1, y-intercept of 25. Question number 4. What is the slope of this line? We already answered that with our equation. It is -1. And why is it -1? Well, if the length goes down by 1, the width would go up by 1. -1 over 1. Down 1, right 1, down 1, right 1, down 1, right 1. All right, your homework. Number 1, you're graphing. Number 2, draw the lines and write the equation. Gives you the slope, gives you the y-intercept. Should not be too difficult, but you need to do both of those things. You can do it right on the next page. Again, not a fan of the formatting, but they do have graph paper for you right here for that problem, for number 2. Number 3, is anybody colorblind?
Oh, I can't see shades of color.
Okay, well there are 4 lines there. Hopefully you can see the colors. Should be green, yellow, blue, and red. It wants equations. Okay, should be 4 of them. If you cannot see them, I can draw them in for you. So you can see them. And then question number 4, pretty self-explanatory, I think. Write the equation, write the equation, write the equation. I think we can handle that. So 1 through 4 for tomorrow.